Right. Well, I'm out and it is clear. And so I've got an observing program. And so I'm out here, sunset, taking my calibration data. So not incredibly exciting, but that's how it goes. So howdy, everybody. Let me. I can sort of position this differently, so you can sort of see the scope and me and everything else. And I'm letting the camera cool down and stabilize a little bit. I'm gonna put the camera on the telescope right now. Back that up a little bit. Okay. Doesn't have to be perfect, but it does have to stay. Once I put it on, it must stay. So who do we got in the chat? 9-inch colas? Hey. Yes, that is my pet cougar in the crate. Shh. Don't tell anybody. Nobody's supposed. How did you find out about that? Okay, so camera is on. Probably not too stable yet in terms of temperature. So I'm going to give that a little bit of time. I need to set up other things anyway. Counter and autosave is going to be off, and we're going to be doing flat. And I'm going to do flats in a different way this time. But I've got to give this a few more minutes. Oh, I've got to get this up here to relieve the tension, because this is a really important connection here. So I like to relieve the tension on there if I can. And we can probably need to point down a little bit. We'll see. We've got a nice bright sky, but like I said, I'm waiting for the temperature on the camera. This is thermoelectrically cooled, and it also has a little fan. But I've set the temperature to 0 degrees Celsius, and right now it's still fluctuating a little bit. It went down to negative 1.5, and now it's up at negative 0.2. So, hey there, Uncle Bill. Hey there, Andy. Nice to see you. I'm taking calibration data because I'm hoping to do an observing run after the live stream tonight, looking at my my list, my first list of target stars, 11th magnitude and brighter. And I'm going to be starting over here in the east and just sort of working my way that way. So it's at negative 0.2 degrees Celsius. And I think if it stays like that over the next couple of minutes, I'm going to get going on these flats. Like I said, I'm going to do the flats in a slightly different way this time. What I have been doing is I've been taking 10 exposures at different exposure times. And what I'm going to do this time is I'm going to get as many exposures as I possibly can, keeping track of the maximum count value, because I really don't want that to drop any more than about 30,000 or so. The maximum that this can go is 65535. It's a 16-bit camera. So, okay, I think we're stable at 0.2 degrees. So I'm going to start taking images, and for these first ones, I sort of need to set my set point. So I'm going to do a 1 by 1, and it's going to be a flat field. These are all the settings that I can have, and I'm just going to do a series. I'm not saving these yet. Oh, I need to this 18, 11, 29, because that is the UT date. And we're going to select that one and save it. Okay. So now I'm going to take my first series of exposures and make sure that I've just arbitrarily set an exposure time of 1 second. So we'll see it's a 1 second exposure that takes about 16 seconds to download. So we'll see what the max value is here. 47,813. That's good. That's good. Okay. So I'm going to go with that. So let's go. I'm just going to start taking the series, and I'm going to turn autosave on, and off we go. All right, I'm taking my first set of calibration data. Yes. So it's pretty nice and bright, and let's see what this next maximum count is. I really, as I said, I don't want to drop below about 30,000 or so. So that was 45,000. Good. So I'm just going to watch this drop, right? I'm just going to let those max counts drop and drop and drop and drop and drop until I hit 30,000, right? So it's at 44,266. So we're doing good. And I'm going to check my files, my data, make sure that it is all there. It is. All right, it's accumulating. So good. And we're at 43,000. So we've got quite a bit of time. Like I said, I mean, what I've got now with this system is pretty good. Well, it's acceptable, right? It's acceptable in terms of photometry, right? I'm seeing about 1/10 of a magnitude, better than 1/10 of a magnitude accuracy, and better than 1/10 of a magnitude precision. In fact, I'm seeing like tens of millimagnitudes, like 0.05 magnitudes accuracy and precision. So that's very, very good. But I want to see if I can tighten that up even more, right? I would like to get to, I mean, crazy as it sounds, but others can, have done it. I would like to get to 0.01 magnitudes, 10 millimagnitudes. If I can get 10 millimagnitude precision with this thing, then things are going to get pretty exciting. So I'm down to 38,500, and I thought I saw something on my teeth there. All right. So yeah, this is called a t-shirt flat. So what I've done is I've covered the front of the telescope with a double layer of white t-shirts that I've made really, really flat, and then I'm pointing at a location in the sky at sunset where it's sort of it's not red or blue or anything, it's gray. It's sort of gray. So I'm looking in that nice gray area, and that will throw a uniform field, hopefully, of brightness onto my camera. Then whatever the camera sees is going to be part of the optical path, and that's what I'm trying to measure here, are all the systematic defects and everything in the optical path. And primarily, so I'm down to 34,000, and I've done 14 exposures, so good. I'm just going to let that rock and roll, get as many as I can. Right, so this part of the data is sort of the critical calibration data, because it measures the optical throughput and also the gain of each pixel on here. Each pixel is like an individual person, and so they have their own characteristics. They react to things differently. Well, I need to measure all that so I can take that out of the raw data, because the raw data is going to have all these flaws, all these things. And okay, 30,917. I think this is probably the last one there. And I'm going to go on to a 2-second exposure. I'm going to download this, and then I'm going to quickly. Okay, so let's go to a 2-second exposure, and I'm going to just jam it again here. And we'll see what the count is. The count should be about twice as many, right? So 30,000 times 2, it should be about 60,000. And I'm guessing it's going to be maybe 50 to 55, but could be wrong. 56,938. Pretty good. I've been doing this a while. So what you can see on the screen here, I'll bring the camera or the smartphone over, is the flat field data. And as you can see, it's got a lot of dust rings, but you can see how it's brighter down here, darker here. That's because there are differences in gain with these pixels here as opposed to here. And yeah, these are just out of focus pieces of dust. It's not necessarily a pretty thing to see, and most astronomers are sort of embarrassed by all of this, but my attitude is this is it. This is what it is. And actually, these are extremely low levels. This program just likes to exaggerate, right? I mean, it likes to stretch the contrast. So this looks really, really bad. Believe me, this is extremely low level stuff. This is like 1 or 2% stuff. So it's almost not there at all. But I'm getting good counts. And so what I'm going to do is I'm just going to continue taking this data, and like I said, I'm sort of doing a different thing here today, in that I am maximizing the amount of flat fields that I have. Now, what I'm going to have to do after this, after the flat fields are done, and at some point, I mean, it's going to get dark enough that I'm not going to be able to do flats. I've probably got another, I don't know, 15 or 20 minutes or so. It's already down to 47,000. But the really, really cool thing is that I am hitting this thing actually right where I want to be. The idea with a flat field is that you want to set the exposure such that the maximum pixel value is about 2/3 of the way to the maximum. So 2/3 of 65,000, you want to say around 45,000, 50,000 or so. So anywhere in the 55,000 to about 30,000 range is what I'm aiming for, because it gives the pixels a nice dose of light. So they're not, seeing really, really faint stuff. They're not being overexposed. They're just right. So I'm down to 43,000. So actually, this is really, really good. I was a little bit worried that it was going to be getting a little too dark. But no, it looks like these flats are going to be really, really nice. So probably what I'll do, right? I did a series of 1-second exposures. I'm doing a series of 2-second exposures now, and I've already done 14 of them. I will most likely do a series of 4-second exposures. Um, and then once all the flats are done, once I'm sort of, you know, looking at the sky and saying, and you can actually tell in the background here, right, how sort of gray that looks, right, and that's sort of the same kind of gray that the telescope is pointing to. See how it's sort of bright and bluish down here, and sort of dark blue up here, but there's this gray area right here, and that's what I'm aiming for. So we're down to 38.4. So yeah, after I take the flats, I'm going to have to take a series of darks too, because these images have a dark signal, which is just like a offset. It's like here's 0, right, and then there's here's 0, right. Here's the dark current, and then everything is on top of that dark current. So I want to be able to subtract that dark current off. So I have to take darks for every single exposure time that I take, because darks actually read the camera out. Um, they let the CCD expose, sort of gather all that dark current, and then shoot it out. So I'm going to have to take a 1-second series of darks, a 2-second series of darks, and probably a 4-second series of darks if things go well here. So I'm down to 33.9. So a couple more of these. It's a beautiful, beautiful sunset. I was a little worried when I got home a few minutes ago, and yes, I'm having to rush. I had to rush. I hate it. But, for astronomy, I'll rush. Um, uh, I was a little bit worried about the wind, because the wind was blowing a little bit. But now it's completely dead calm, and it's beautifully clear, wonderfully clear. Probably start seeing Mars pretty soon. So I'm at 31.9, so I think I'm going to go to my 4-second exposure here. Okay, so here goes my series of 4-second exposures. And we're going to let that crank for a while. I'm going to see what the data value is. It should be up around 50,000 again. That's what I'm hoping for. Should be, I doubled the exposure time. I should double all the counts. Yeah, 55,800. That's a tiny bit high, but I'm not going to complain. We've got photons. So cool. Okay, so this is just going to run, and I'm going to look at my data here and see how that all looks. So yeah, see, so far I've got like 44 flats, and I've been stopping at about 30. So yeah, I'm gonna have a ton of flats here, and that's good. That's very good. We like it. So 52.3, cool. All right, I'm gold. So now I can finish this up. I can go inside. I'm going to leave this running, right? Because the telescope isn't, it's been inside, so it's not really at ambient. So I'm going to let it get to ambient. That's going to affect the flats a little bit, right? Because wasn't exactly stable or anything else. The camera was cooled down though, so we should be good there. We're at 49,000. So yeah, this all looks really, really good. But now with my calibration data, right, with my flats and my darks, and there's actually a bias as well, but the bias is sort of included in the dark, so I'm not really messing with that at the moment. Uh, with that, I can actually be preparing for the actual observations, which is going to be I'm still working on sort of characterizing this system. So now that I've sort of done this long, painful preliminary analysis, where I'm just like, let me just look at stars and see what happens. That is very encouraging. So now it's like, okay, now uh, I've got a new set of targets, which is all of the stars, 11th magnitude or brighter. And I want to see. I'm not doing any science or anything on those yet. I just wanted to measure their brightness and then compare what my measurement is to a standard list like Gaia, right? I've been using Gaia uh, for all of this, and comparing them and seeing, how well do my measurements match up to, you know, a catalog that is supposed to be correct. Um, so we will see, and I've got a preliminary list of like 38 stars in a 4 degree square field of view, 2 degrees by 2, right? There are 38 stars that are 11th magnitude or brighter in that small field. And I'm going to go through each and every one of them one by one, get about 100, um, um, yeah, um, um, about 100 2-second exposures, which is going to take about a half an hour or so to expose and download. So I'll probably do 3 or 4 stars tonight, and that will be the start of this project. It's going to take me, to do 38 objects. It's going to take me 19 hours of just scope time. Not to mention all the calibration, not to mention setting it up, not to mention all the processing and all of that. So we're down to 33.5. And ooh, we've got 57 flats so far. So I think I'll let this get to it's at 32,000 now. Let's see what this next one is. It should be about let's go. Okay, so there's 30,775. So we're pretty much there. I'm gonna Yeah, so I've got 60 images. I'll let this last one download and then I'm done. I just gotta take my darks. Okay, so now I can take my darks, and I think what I'm going to do is I'm going to save this a different way. Do that, and I'm going to reset this to 0. And I've got it on dark, and I'll do my 4-second exposures. Now here, I am going to set the number of exposures, but instead of doing 10, I think I'm going to do 20. I've been doing 10. I'm going to do 20 because that's more data. Okay, so here we go. My series of dark 4-second exposures. I've got the autosave on. I'm ready to rock and roll. Okay. So now I'm taking my darks. So technically I can take the cover off the telescope and everything else, but right now I'm not going to mess with it at all. I'm just going to take my darks. It is 0 hours 34 minutes UTC. Very cool. So here's an example of the darks. Show you. Bring it in close here. Show you what the darks look like. Get this out of the way. You can sort of see it there. I guess there's a little bit of a glare. So this glare is just a reflection of the sky, but you can see, yeah, you can see some. There's a lot of so-called hot pixels here. I don't know if you can see those or not. These little tiny white dots, and then there's these whole columns that are messed up. So those are the kinds of things that I don't want in my actual data. So by taking this data, I'll be able to remove that because I know exactly what it is. And those will be gone. So cool. All right. Well, I was. You guys know how much I hate to rush. I hate to rush. So, rushing home and zooming out here and getting all this set up and everything is was a rush for sure, which I hate. But for astronomy, I will definitely do it. So, and yeah, I've got some really, really good flat data here. So, yeah, pretty happy with that. Just taking the darks now, so pretty much the excitement's over. We can certainly take a look at this sunset sky here, which you can't see much of. But there's the top of the telescope right there, and here is the parallel port cable. All right, I like it. I like it. Cool. That's a nice silhouette there. So exposure 10 of 20 so far. Here's the scope. So this is a Celestron Nexstar 8SE telescope, and this is a S-Big ST7 7ME, I think is what it's called. It's a 16-bit CCD camera. Really great, really great in terms of the camera itself. It's low noise. 16-bit means it has a very nice dynamic range. Format's kind of small, and my field of view is kind of small. So my field of view on this, and I'll back up a little bit here. My pixel scale is almost 1 arc second per pixel. It's about 0.93 arc seconds per pixel. My format is 765 wide and 510 width and height. So yeah, pretty small format, but the pixels are 13 micron pixels, and that's a nice size. I like that size. Keeps the noise at bay because it's a little big. 6 micron or 9 micron are a lot noisier, and 13 is a good number anyway. So 16 out of 20 on the 4-second exposures. Then I'll go to 2-second, and then I'll go to 1-second, and then I'll be done until after the live stream. So yeah, wow. So this live stream has already been going for 30 minutes. Hey, it's a beautiful sunset though. Beautiful sunset, as you can see. Hopefully that's showing up relatively well. So nice to see everybody here. There's a few people watching. Good. Just collecting my calibration data for tonight's observing run. Let's see, I should be able to see Mars by now. Where is it? Oh, there it is. Actually, Mars is almost on the meridian, almost due south, and probably about 40-ish degrees up in elevation. Okay, downloading 19 of 20. Of 20, here we go. So the maximum count there was about 5,400. Okay, there's our darks. Darks are done. I'm going to go to 2-second exposures. Take a series of 20 of those. Here we go. Bammo. So the max value now should be about half, right? So it should be about 2,600, 2,500. Let's see what it is. Got some clouds to my north over here. Yeah, so I'm at 2874, so that's okay. Got some bats flying around out here. Various moths. It's gonna get pretty cold tonight. I think this morning when I got up it was 28 degrees Fahrenheit. So yeah, it's a little cold. I'm gonna have to put on my my warmies for tonight, because yeah, I'm gonna be out here for at least a couple hours, probably a couple hours. I want to get I guess at least 3 stars, if not 4. So we'll see how that goes. Yeah, so just taking flats. I think there's not much more. There's not much more to it. Let's see. Can I zoom in on the sunset over there? Get a nice profile. It's not focusing really well. I don't really know how to focus. I don't think that do anything. No, that's not doing anything. That's not doing anything. Yeah, I'm not seeing how to focus. So unfortunately, you're gonna be a little. That's kind of nice. I think we just saw a bat flying through the field of view there. So, all right. I think that I'm going to get out of here for now. Just going to take the rest of my tricks, and then, like I said, I'll go in and chill for a while. We'll do the live stream, and then come out here and see if I can find some bright stars out there. So, okay, well, I think for now I'm going to get out of here. So, peace, cheers, and all that, everybody. I will see you. I'll see you in a little bit over than. Yeah, I'll see you in a little bit more than an hour. All right, take care, everybody. Bye.